In this session, a pipe flow problem will be solved. Here is the sketch of the pipe system. At inlet 1, water velocity is 1 meter per second. Water temperature is 300 K. At inlet 2, water flow velocity is 1.5 meter per second and the temperature is 350 K. The two water flows mix and exit on the top boundary. This problem will be solved using ANSYS Fluent. Firstly, I open ANSYS Workbench. Double-click Fluent. I need to complete geometry mesh setup and solution. Double-click geometry. First step, choose unit. Click File, Space Claim Options. Click Units. Here, choose meters. For grid spacing, choose half meters. OK. Second step, draw the pipe system. Look at this diagram. Firstly, draw the main pipe. We look at the axis of this pipe. One horizontal part, one arc-shaped part, and one vertical part. I draw the axis of the pipe first. I rotate it slightly. This is for drawing sketch. And I need to choose the plane for drawing sketch. The axis of the main pipe is on XY plane. Draw a straight line. One end is -12 to 0, and y is -6. Then I draw the curved part. Center is 0, 0. Starting point. End point, 90-degree arc. Vertical part, 6, 0. Length is 8. Finish. Now I want to draw this circle. 0, negative 6, 0. Diameter is 4. Sketching. Choose the plane. The circle is on YZ plane. Draw a circle. Negative 6. Diameter is 4. Finish. I sweep this circle along this axis. We will get a main pipe. I choose pull. Choose this circle. And this is pull or sweep along lines. I choose one line. Second, and I hold the Control K of keyboard. Choose 3 lines. This is to sweep through the whole lines. Main pipe finished. Look at the sketch. I need to generate the smaller pipe. Diameter is 3. Firstly, I draw the vertical axis. Sketching. Choose plane. XY plane. Draw a line. Vertical axis of the pipe is 6 meters long. Finish. Then I need to draw a circle. Diameter is 3. Choose sketch. Choose the plane. Circle is on Y plane. And draw a circle. X is negative 8. Diameter is 3. Finish. I need to move it downwards. I choose move. So I choose 3-dimensional view. Choose move. And this circle. I pull it downwards. It should be 12. Finish. Second step. Sweep this circle along this vertical line. Choose pull. Choose this circle. And the line, I choose this vertical line. I choose sweep. Finish. Now I have finished the geometry. I choose File, Save Project. I save it in my local computer. Name it as Project Pipe Flow. I save it. Second step, Mesh. Double-click Mesh. This is geometry we just built. I rotate it slightly. Firstly, I choose materials. Double-click materials. You click geometry, and this is name. I can change the name. For example, I change it to pipe flow. Then if you click this pipe flow, look at the material option. You need to choose it to fluid. Second step is to generate define the boundary. Define the boundaries. This is for choosing surface. I choose one surface. Right-click your mouse. You give it a name. Choose create named selection. I name it as inlet 1. Okay. Then on named selection, you have inlet 1. I rotate it slightly. Let me see another inlet. Choose surface. Another inlet. Right-click your mouse. Create name selection. Name it as inlet 2. Okay. Choose surface. Choose all the pipe walls. You choose one wall. Hold the key, Control K of your keyboard. Second, third, fourth, right-click your mouse. Create named selection. This is, I call it a pipe wall. Okay. I rotate it slightly. Let me see the top surface. I choose the top boundary. Right-click my mouse. Create named selection. This is outlet. Okay. Now you have inlet 1, inlet 2, pipe wall, and outlet. Next step, finish the mesh. If I click mesh, right-click my mouse, and update. You have the mesh. This mesh is not good. It's very coarse. It can't simulate a flow accurately. Now I'm going to refine the mesh. One thing I can do is, if you look at this default element size, original size is 1.428 meter. If I reduce it to half meter, for example, then I click mesh, I update. The mesh density was reduced. Density was increased. The element size was reduced. When we simulated the flow problem, we want to have a very dense mesh around the boundary. Because around the boundary, you have boundary layer flow, where velocity changes very fast. You need to have high resolution mesh. We can use inflation layers to create dense mesh around the boundary. To do inflation, you click mesh, right-click your mouse, insert inflation. You need to choose the geometry. You click this whole volume And then you see geometry is highlighted. You need to choose it. You click no selection, apply. You have chosen one volume. Boundary is highlighted. You need to choose the boundary. You choose this boundary. Click one boundary. If you want to choose multiple boundaries, hold the Control key on your keyboard. Click second boundary, third boundary, fourth, and click here, no selection, apply. You have chosen the surface for doing inflation. How many layers do you want to have? If I want to have, for example, 10 layers, you put 10 there. Okay? And transition ratio, growth rate, you can adjust it to adjust the inflation layer thickness. Now, I don't make any further adjustment. I just update. You look at the new mesh. You have 10 layers. We call it a structured mesh near the boundary surface. So this 10 layers is for simulating the boundary layer flow accurately. Now, I finished the mesh. You can further increase the mesh if you are doing project. Today, I just want to introduce the method, how to do the inflation, how to change the mesh density. So I don't want to further increase the density. I choose Save Project here. Mesh finished. Go back to Workbench. Setup. Double click. Setup. Here, our case is 3D, so you can't change to 2D. And then, if you are doing your project, you can choose double precision, so increase the accuracy. And you can increase the process number or CPU number. For example, I want to increase CPU number to 4. We are not using GPU, so you don't change this. I start. Close this instruction window. This is the mesh we have just generated. In setup part, firstly, we need to choose models. We are solving temperature also. If we want to calculate the heat transfer, I need to switch on energy equation. Remember, if you want to solve heat transfer, switch on energy equation. This wishes. Okay. You need to choose a turbulence model, you don't choose laminar flow because in our case, flow is turbulent. Except laminar flow, all these options are K epsilon, K omega, transition, KI omega, they are all turbulence model. So you can choose any of them. K epsilon, K omega are very popular. So here, I choose K omega model. Then, okay. Next step, we don't have radiation or other things. So next step is to choose materials. Materials in fluid part, okay? The fluid is air, but in our case, we are simulating water flow. Then we need to change air to water. I double click air. And then how do you add water in? You see here, there is a Fluent database. Here saves all the fluids. I click it. And then from this list, I choose water liquid. Then I choose copy. Once I choose copy, close it, you see water fluid has been there. And air is also there. Then I close. If I want to delete air, I double click it. If you click delete, you can't delete it. And why? Because air is used by pipe flow. So how to fix this problem? You go to cell zone condition, fluid. Here is for choosing fluid for this zone. I double click pipe flow. And you see here material is air. I need to change to water liquid. Then okay. And now I delete this air. You see I can delete it. I close it. Next step is choose boundary conditions. I double click boundary conditions. All the boundaries we have defined in mesh generation section has been listed here. Inlet boundary, it should be velocity inlet. And if you click this list, you choose velocity inlet. Then you need to give velocity, okay? So you can click edit. Momentum is to give velocity. Go here. This is velocity inlet 1. Velocity is 1 meter per second. Water temperature is 300 K. I give velocity is 1 meter per second. Go to thermal. Temperature is 300 K. I don't need to change. Okay. Now I go to inlet 2. It's also velocity inlet. I edit it. Look at this picture. Inlet 2 velocity is 1.5 meter per second. Temperature 350 K. Velocity 1.5 meter per second. Go to thermal, change this to 350 K. Okay. And pipe wall. Pipe wall is all the surface of the pipe. Wall surface is already been wall. If it's not, you need to correct it. And then edit. Momentum, wall is stationary. You use non-slip boundary condition. And roughness height is 0, that means wall is smooth. And the thermal, we assume wall is actually totally insulated. Then you give heat flux 0. That means no heat going through the wall. If you know the temperature, you give temperature. But in this particular example, it is insulated wall, so heat flux is 0. I click OK. Outlet is pressure outlet, okay? And when we do CFD simulation, very often, but not always, we choose velocity at the inlet and pressure at outlet. And pressure at outlet, you just give 0 pressure. Okay, pressure is 0 Pascal relative to atmospheric pressure. Okay, I finished the boundary condition. Now, it's ready to do the calculations. Before the calculations, I want to mention, when you do the simulation, we use iteration method. Then I want to mention this residue. So this, when we do simulation, you can monitor how accurate this velocity, energy, K, and omega is. Okay, this is a law error. When we do iteration, if error is less than this, the program will be stopped automatically. Okay. If you don't want to show error of something, you just deselect this item. Now I'm selecting all, then OK. Initialization, before you do simulation, you need to initialize. I just click initialize. Don't need to change anything here. And you look at the bottom, initialization has been finished. Okay. And then finally, run calculation. Run calculation. Time step. It's better to choose automatic. Let the ANSYS to calculate it itself. A number of iterations. Okay. Usually you need to have a very big number, and the program will stop before the error has met requirement. I put 50. That means I'm going to do 50 iterations. Then I calculate. When the ANSYS is running, you can see this error bars. Continuity equation error, velocity error, they always reduce. But sometimes it reduces very slow. Now I finished the 50 steps. I click OK. But if you look at the continuity equation, the error is about 10%. If you feel this error is not really sufficiently small, you can run another 50 steps. You don't need to do anything. You just click calculate. If you want to run more steps, you increase this number. Now I just run another 50 steps. I click calculate again. It will start from 51. Now you see the error actually reduce very slowly. Finished. If you are doing the project, you may need to continue run this simulation for maybe a few hundred steps until this all the errors is less than at least 10 to minus 2. I just want to introduce the procedure, so I don't want to continue. Assume now we have had the results. Now we want to show the results. You can show the results in some diagrams, contours, or velocity vectors to visualize the results. How you are going to do that? You can go to results part, click graphics. Okay. Graphics, if you want to show mesh, you double click mesh. Then, for example, I want to show mesh on the wall only, you only select wall, you display it. Then this is mesh on the wall. If you want to show the mesh on inlet, you click these two inlets, you display it. On outlet, you display it. You see, this is outlet. Inlet is hidden. Okay. If I rotate it, you can see the mesh on the inlet. This is for showing the mesh. You can also show contours. Showing contours, for example, I want to show pressure contour on the wall surface. Then here you choose pressure. And here you choose the wall, pipe wall, you displace it. So this is pressure contour on the wall surface. If you want to show the contour on the outlet, okay, so this outlet is shown. You can also show temperature. If I show, here I choose temperature, okay. Then I choose pipe wall and outlet. I only choose pipe wall display. So this is temperature on the pipe wall. I rotate it a little bit, okay. If I want to let the z-axis face me, I click z-axis. Okay. Here we can only see the temperature or pressure on the boundary. We can't see temperature, pressure inside the fluid. So in order to see temperature inside the fluid, we need to create a new surface. For example, in this case, XY plane is symmetric, go through the center of the pipe. And if I want to show temperature on XY plane, that is symmetric plane, I create a new surface. And is plane, okay, is plane. Here you choose XY plane, XY, okay. You can also choose point and normals. In old version, you gave a point because XY and the plane go through 0, 0, and 0. And the normal direction is in that direction. And I gave it a name, XY. Okay. Then I create, close it. You see, you have a new plane. If I want to show temperature in new XY plane, okay, and let Z facing me. So this is exactly at the center of the pipe. You can see the flow, hot water is red, cold water is blue, and they mix, and this is the boundary between these waters. At this point, they nearly totally mix, but still not. You need to have a longer pipe to guarantee these two fluid is actually totally mixed. So that is contours. We can also show other diagrams. I close these contours. If you want to show vectors, you click vectors. And I want to show velocity vector on XY plane. Then I display. But it is extremely dense. Okay, very dense. If you want to show less point, you can increase this number. For example, I skip 6, you display. You see now it's clearer, right? 6 may be too much. I skip 3. Now you see flow in here, and then you can see the vectors. Okay. If your mesh is too dense, you can skip, and the scale I choose 2 to see what happens. You see vector become longer. Okay. If I choose 3, for example, you can choose style. Okay, I just choose arrow instead of 3-dimensional arrow. So this is only arrow. Okay, that is vectors. And then I close it. You can also do path lines. You double click path line. So what is path line? Path line is you track the particle. Okay, if you release particle on inlet, this particle will flow together with fluid. And if you track the particle, you have a path line of every particle. Now, I want to release particle from inlet 1 and inlet 2. And then I display. So you see the path line, okay? The particles, every particle go into the pipe system, but it's very short. It stopped here. Reason is here. If you want to see the whole path line, you need to increase steps. For example, I increase to 300. I display. Now you see you have path lines in the pipe. If I rotate it, okay, this shows how water is actually flowing, but it's too dense. You see here, it's all the path lines are mixed together. So how do you reduce the number? You can choose scape, okay, increase the scape numbers. Then you see number was reduced, and here you can see clear. And if I further scape, okay, so maybe this is better than the original one. This is a path line inside the pipe. Now I have introduced the velocity vectors, contours, mesh, and path lines. In the tutorial class, you can do some practice. Okay? From this path line, you can see there is a vortex here. Once you finish this diagram, and how you are going to put it in your report, okay, if you need to write a report. And also, when you do that, you're better to make this diagram fill in the full screen. You don't have a big screen and with a small, very small diagram at the center. Don't do that. How you are going to save it or put it in the report, Word document. So what I do is I choose, right-click your mouse, choose Save Picture, and I choose JPG format. I save it, and I save it in a folder, okay? For example, I save it here. I say this is path line, and enter. Now I go to that folder. You see, you have a path line, and the format is JPG. If I open it, it is exactly the path line we have generated. And when you save your picture, you don't do the copy the whole screen. Okay, if you copy the whole screen, you have this part that all these windows are useless. You need to save it in a picture. Now, how you are going to copy it in the Word document? If you are writing the report, okay, you open a Word document. Then you can choose Insert Picture. Then you go to the folder where you save the pictures. And now you have this diagram in your report. Then you can discuss these results. Now I finished this session of pipeline